Today we are going to learn something about real mode segmentation. While operating in real mode, as we have seen, the segment register, which happens to be 16-bit, and the offset that happens to be again 16-bit, plays the role. By using 16-bit segment address and by using 16-bit offset, system calculates 20-bit physical address. To understand the process of address calculation, let us consider the access to a code segment. Whenever code is fetched by the processor to the microprocessor side, it uses CS and IP registers as default. Here CS is also 16-bit segment register and IP is the instruction pointer, which is also 16-bit. Now in this case, the contents of code segment register is shifted 4 binary positions to the left, and then the least significant 4 bits are appended with 0000, and contents of IP as 16-bit is added to it, so that effective 20-bit physical address is computed. Let us take an example. Assume contents of CS to be 1400H and contents of IP is equal to 0200H. Then the physical address will be 1400 plus one more hexadecimal 0 appended to it as 4 binary zeros, added with the contents of instruction pointer. It comes out to be 002. What happens to be 14200H. So this is the final 20-bit physical address. So whichever segment the system is referring to and whichever offset, because this particular pair of segment register and offset will vary depending on the type of access. For example, if you are accessing the data segment, by default DS and the offset can be a direct like this, or it can be in the form of index register like this, or it can be in the form of pointer register like this also. So by using this pair, system calculates 20-bit physical address. So it is a fair and straightforward that in real mode the segment address is always 20-bit, which forces the system, the size of the segment maximum cannot exceed 1 MB, as 2 to the power 20 happens to be 1 megabyte. So the maximum segment size in real mode operation of 8036 is 1 megabyte. It cannot exceed that, as we have 20 lines for the address, 20 bits for the address. We cannot go beyond 1 MB. Minimum size may be 1 byte also. Now, as far as segment translation is concerned, it is a fair and straightforward in real mode. It is very complex as far as the protected mode is concerned, because whenever system switches from real mode to protected mode, system uses the full resources for segmentation, and certain nomenclature of the registers also change, and for that it becomes apparent to exactly examine the segmentation process. Once again, I remind that segmentation is a partition of the memory depending on the content, so that the contents will not mix in each other, because this intermixing may increase the burden on the programmer. So program is relieved as the contents are separated as code, data, stack and so on, depending on the usage. Now let us see what is the mechanism of the system when segmentation is performed in protected mode. Once the system switches to protected mode, there are certain tables system maintains as far as the whole life cycle in the protected mode is concerned. Let us understand the name of these registers and the associated tables, which are going to play a very crucial role as far as assigning memory to various resources are concerned. So to start with, the system maintains one global table with the name what stands for GDT, which stands for Global Descriptor Table. Then it maintains LDT, which stands for Local Descriptor Table. And IDT, which stands for Interrupt Descriptor Table. These are the very crucial tables which are maintained by the system to start the whole protected mode mechanism.